Hey folks, this problem is a very interesting one, so let's jump into it. But before we do, if you're new, welcome. And if you're returning, welcome back. If you're a frequent visitor to my channel, you will know that I normally have a Jupyter notebook on the right hand side of my screen, and I've got the Hackerrank problem on the left hand side. I'll open the problem on the left hand side, we'll have a look at that together, and then I'll explain it to you on that white panel on the right hand side. So this one is called piling up. It's about piling up cubes under special conditions, and the success rate for this problem is only just above 90%. It's a rather difficult problem to solve. Let me show you how to make it easy. So if I press solve challenge, there is an explanation for you written right down here, but let me make it easy for you. You will be given a number of lines from the user, something like this down here. The first line that comes from the user will tell you how many times do they want to play this game. If you consider this a cube game, how many times do they want to play? This user wants to play 2 rounds. This is the information for round 1, and this is the information for round 2. So essentially, I will be getting 5 lines of code from this user. Now that we know for each round, there is a number. In this round, it is number 6. So that means that you will have 6 cubes, but different sizes. How do I understand the sizes? Well, the sizes are the next line. So you can see that there are 6 cubes. One of them is of size 4, the next one is 3, the next one is 2. So you can think of this as a size 4 set of cubes, then a size 3, then a size 2, then a size 1, then another size 3, and another size 4, put together in a horizontal manner. So what is the challenge? Here is the challenge. There is a horizontal row of n cubes, so we know that for round number 1 in the example below. The length of each cube is given. Yes, we did see that. You need to create a new vertical pile, so we have them set like that. Then we have to pile them up on top of each other vertically so that the new pile should follow these directions. What are the directions? If cube I is on top of cube j, so if you've got j here and you put I on top of j, there is one condition. The size of j, which is at the bottom, has to be bigger than the size of I, which is on top. For example, if you've got 3 here, you can put 2 on top, and then you can put 1 on top. But if you've got 3 here, you cannot put 4 on top. You can't do that. The top one should be smaller than the bottom one. So that is super important, and that's the key for solving this problem. Here is one more thing that you need to consider. When picking the cubes, you can only pick the leftmost or the rightmost cube. You can't pick from the middle. You can't do that. So print yes if it is possible to stack all the cubes. I wish this was written in a better way, but trust me, I found it really confusing too. So let me show you an example right down here, which the answer to it is no. The software you write should say no in this case. So I've got 1, 2, 3, 8, and 7. I can either take 1 or 7, right? If I take 7, okay, I will put 7 at the bottom. I'll put 7 there. Now, I need to find something that is smaller than 7, because that's the rule, right? I can either take 1 or 8. Well, 8 is not smaller than 7, so I can't pick 8. I have to pick 1. So I'll put 1 here. Now I am left with 2 and 8, because I have used 7. I have used 1. Now I have 2, 3, 8. Is 2 smaller than 1? No, it's not. Is 8 smaller than 1? No, it's not. So I have to print no. This game cannot be completed, or all these cubes cannot be stacked, right? But there is another example here. 1, 2, 3, 7, 8. So I can either take, let me delete these two. I can either take 1 or 8. I'll take 8. All right. Then I'm left with 1 or 7. I'll take 7. There you go. And I'm then left with 1, 2, 3. Well, I take 3 and then I'll take 2 and I'll take 1. So I can print yes here because it's smaller, 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 and smaller. I can finish the game right here. But how do we code this? This is a bit of a weird question for us. How do we code this? Let me show you how we do it. Let me just clean up this cell. I don't really need those numbers. And I will go down to this example. For now, I will not really worry about the number of rounds the user wants to play. Once I know how to run one round, then I can make a for loop that repeats the whole round. For now, I will not worry about the number of the rounds of the game. So what I will do, I will start from this line. So this line is when the user tells me how many blocks they have. I will start with n, which is the integer form of the user input. So the user gives me their input. I know that the input function always gives me a string. I just want to convert this to an integer. Once I have done that, I can run it, and the user gives me 6. So I am replicating exactly what we have. User gives me 6, I press enter, and if I print n, you will see that it is 6. So let me delete that. The next thing I need is the size of the cubes. So if I call this cubes, I can take an input from the user, but if you have seen my previous videos, you will know that this doesn't really help because the user is going to give me a series of numbers as they are, and they come with one piece. I don't need that. I need to break them into integers. I don't need 4 space 3 space 2 blah blah blah. I need 4, 3, 2, and the rest of it. So what I will do, I will try to first split them based on their spaces, and then I have to map them into an integer function, which will be through this code. Right, now let me run this one, and I will just copy the user's input from right here into there. And if I print the cubes, you will see that I have converted them into a map object. If I convert them into a list, because map objects cannot be really viewed, paste it again, and if I print the cubes, you will see that they are 4, 3, 2, 1, 3, 4. So I have broken them into numbers. Right. Now, let me get rid of the print because I don't need that, and I will move this line just under here so that it's nice and tidy. User has given me everything I needed to play this game. Now it's my turn to take either the rightmost or the leftmost and then decide if I can keep stacking vertically. In order for me to do this, let me take an infinite number, which is a huge number, and I will keep that as a criteria for me to measure things. You will soon understand what I'm thinking. Let me do that first. I'll say something like a current top is the infinite number. This will allow me to start with an infinitely large top cube. Then once I pick any number from either the right-hand side or the left-hand side, I can compare it against the infinity. But this very soon will make sense. Let me run that. All right, I will write a for loop that goes through each one of these numbers. So 4, 3, 2, 1, 3, 4, and performs that comparison. Let me show you how. For something in the range of length of cubes, if I print this underscore, you will see that I am going through each element, but not itself, but just the index, because this is number 0, number 1, number 2, number 3, number 4, number 5. And that's what I'm seeing here. That's the index, not the actual number. Now I need to compare the right-hand side and the left-hand side and see which one is greater. So if I go ahead and say, let me make a condition, and in my cubes list of number, if index number 0, which is the leftmost side, is greater or equal to cubes that sits on -1, index -1 will be the rightmost hand side. If index 0 is greater than index -1, it means that I've got a bigger number sitting on the left hand side, and I will pick that as a bigger number. I think that's a good rationale. I just want to find the bigger on the left-hand side or on the right-hand side to put at the bottom of the vertical pile. So I will do that. If I say, is the left-hand side greater than the right-hand side? If that's the case, I can define a chosen cube to be index 0. I will feed the biggest number into something called chosen cube. Once I do that, I will just get rid of index 0 because I have taken it out. I don't need it anymore. All I need to do is to say, all right, now cubes is everything after index number 1 because I took index 0 and I have saved it in chosen cube. Isn't it fun? But that's not the end of this if statement because maybe the left-hand side is not the bigger one. Then I can say if the right-hand side is the bigger number, all you need to do is to take chosen cube from cubes index -1, which is the rightmost hand side. But still, I need to get rid of it. So cubes will be cubes, everything but -1. Choose everything but not the last one because I have taken and saved it in chosen cube. All right, now let's press enter twice. I have another condition that I need to set. My condition will be using that infinite number that I selected up the top. I will ask a question. I will say, if what you have selected is greater than your current top, then print no. Which means if you have selected something for the bottom of this pile, and if you find something that is bigger than that, then this game is over. You can't really do it because the fundamental of this game is the bottom should be greater, then smaller, then smaller, then smaller. But if you find something that is bigger than this, you can't continue this game. But this doesn't have to stop us because sometimes the chosen cube is not greater than the current top. Then in that case, the current top will be overwritten by chosen cube. Once you override it, all you need to do is to print yes. Because in that case, you haven't found anything that is larger up the top, which means that you can put the bigger one at the bottom, then the smaller one, then the smaller one, and the game can continue. I will run this and I will run you through why the answer is yes. Let me show you the cubes here. So when I print the cubes, you will see that I've got 4, 3, 2, 1, 3, 4. How will it start? The for loop starts as long as the cubes. So the first question is the leftmost cube element greater than or equal to the rightmost element? Well, they are the same, okay? So we will take the one at index 0, which is this one, and choose it as the chosen cube. So chosen cube becomes 4 now. And our cubes list will be from 3 all the way to the other 4. So we got rid of this one, we saved it into chosen cube, and we made our list smaller. Does this run? No, it doesn't run because either these 2 or 3 lines run or these 3 lines run. If chosen cube, which now is number 4, is greater than the current top, which is infinity, it's not correct, it will not print no. And it will replace the current top, which is infinite, by 4. So now the current top is number 4. We go back up again. Now we are stuck between number 3 and number 4. Is 3 greater than or equal to 4? No, it's not. So these 3 lines will not run, and the next 3 lines will run. The chosen cube this time will be this number 4. And then we will limit this list from here to there, because we dropped this last one into chosen cube. So now we're left with 3, 2, 1, 3. Is the chosen cube, which is this number 4, greater than the current top, which was number 4 at the back in the previous round? Is it greater than? No, it's not great. They are equal. So, okay, this is not going to print no. And current top will be equal to chosen cube. Again, 4 goes into current top. We go back again, and this continues until the whole for loop is finished. So congratulations, you have made the bare metal bones of this problem. all we need to do now is to make it the number of rounds the user wants, because if you remember, I skipped this line because I didn't want to really care how many times the user wants to play. I wanted to show you how to play the game. So let me just do a bit of cleanup. What I will do, I will copy all of those lines and I will place them here because they're part of the code. I also need this line and I will place it here. And now I can go up and do a bit of house cleaning because I love to keep my code really clean. And I will run this again before talking about the rounds of the game. Let's run that. And let's see, the user has got 6 numbers. I will paste 6 right there. And now the user has got the list of numbers here. I will paste that there. And you will see that yes gets printed. What if I tried the second round of the game? Let's try it. Run that again. This time the user has got 3 numbers or 3 cubes. Press that. And they are 1 space 3 space 2. And it tells me it's a no and then a yes. Well, it's because of my code structure, because when this runs and no is printed, this yes should not really be printed. What I really want to do now, I want to make this into a function. I will define a function here and I will call it define a function that checks cubes maybe, and I will feed cubes into it. If I do that, then I can get rid of print because it's not really ideal, and I will go with return. So either return yes or return no. So let me also make sure everything is indented, because when you define a function, everything under that should be 4 spaces to the front. It's called indentation. All right, let's do this. All right, one last thing. I need to move these input functions out of this loop. So I will just cut them from there and I will paste them down here. You will see what I'm doing. And next time when I want to call this function, I will simply call it like this. So copy that and I will paste it underneath. So this time what I'm doing, I'm going to be asking, hey, just take the inputs, right? And then take the cubes list, which are these 2 lines, and feed them into the checks cubes function. If I run this, let's say round number 1, there are 6 blocks. And here are the numbers of the blocks. I'll paste them here. I haven't run this one. Let me run it again and run this again. 6 and paste that there. And you will see that yes is the answer for the first problem. Let's try the second problem. Run that again. There are 3 cubes there. And it's 1 space 3 and space 2. You will see that no is the answer. So I have defined the solution for the problem and hope that it really makes sense. If you think it did make sense, leave a comment and tell me how did you make sense of it. And if it is a problem, if you have a question, put your question down there and I'll come and help you. So let's make sure we consider how many rounds the user wants to play. It's very easy. All I need to do now is to define another loop and another input from the user. So I will ask the user, hey, how many rounds do you want to play? They will say, I want to play 2 rounds. I will say, okay, if you want to play 2 rounds, I will let you to run a for loop, and for each round, you can run the functions that I have provided for you. So I will just copy those lines and I will paste them here. Just make sure they are also indented, and look at this now. Run that. This question is, how many rounds do you want to play? This user says, I want to play 2 rounds. So put 2 there. Says, okay, for first round, how many cubes do you have? I've got 6 cubes. What are the list of sizes for that one? Let me copy them. I will copy them here. All right, that was round number 1. Now for round number 2, how many cubes have you got? I've got 3. And what are the sizes? It's 1, 3, 2, just copy and paste. It will not print the answer unless I put a print function just behind it. Let's run that again. So 2 rounds, 6 cubes first time, and here are the sizes. Put that there, and you can see that yes is the answer for the first round. And for the second one, I've got 3. It is 1 space 3 space 2, and I've got the no right after it. What do I copy across to Hackerrank? Well, I will first need this function, so paste that here. I don't really need these ones because I've already copied them down here, so I can just get rid of them. And the only thing I need is copy these lines. Let me extend this window a bit more so that the indentation looks good, and press enter and go back and paste everything down there. So what I will do, I will run a test. Let me move my face to the other side. Let me run this code and see if it works. There might be some errors. I'm not really sure. No, there are no errors. Congratulations. So that passed one sample test case. So ta-da! And now all I need to do is to submit code and hope that every case will pass graciously. You can see that 2 of them have passed. We're not sure about 1, 2, and 4. Let's wait for those ones. 4 has passed. 1 and 2 have failed. It's because of a time limit. These codes have to be optimized for Hackerrank to be running in a specific time. I've written an optimized answer. I will put it in my GitHub so you can have a look. But for the purposes of this exercise, I just wanted to show you how to solve this problem. Let me paste the better code and show you if it runs. Right, here is the optimized code that I will put it in my GitHub so that you can download. I will also try and run it here. Let me first run the code like this and hope for the best. Yep, that did run. Let's submit the code a bit further and all the test cases should pass. So this answer is more optimized because it uses while loops and it just makes it a bit easier for Python to run. The answer will be in my GitHub repository and the link to that will be in the comments area for you to copy. But I will leave that on the screen if you want to pause and take note of this screen, so you are more than welcome to. So that's the first part, and if I scroll down, that's the second part. Pause and take notes. And if you like this video, hit the like button, leave a comment for me, share it with your friends. That means a lot for us creators. Thank you.